So now I'll create an animation blueprint for our character. So in the blueprints folder, I'm gonna right click and create a new folder. I'm gonna call this Anim Bp. I'm gonna right click, go to animation tab and create animation blueprint. This will be from our SK mannequin. Create, I'm gonna call this bp underscore ABP animation blueprint underscore layer character. Alright, save everything. Now I'm gonna open the BP third person character. I'm gonna select the mesh and I'm gonna set the animation blueprint to ABP underscore player character, which is this. So we need to change some settings to our character movement component. So I'm gonna select the character movement component. So the first thing is we need to set the acceleration to 1000 and we'll set the braking friction vector to 0.5 and next thing is ground friction. I'm gonna set it to 5 and for now max walk speed will get the speed from the animation in next. So I'm gonna set the braking deceleration walking to 1000. So these are few parameters we need to update. Max acceleration to 1000, braking friction factor to 0.5, braking deceleration walking to 1000 and rotation rate to 0 and false everything. Alright, so this is our player character properties. And next thing, I'm gonna open the ABP animation blueprint and here I'll right click, I'll go to the animation layers. I'm gonna call this base locomotion layer. So here's our base locomotion layer. I'm gonna search for state machine. I'm gonna call this locomotion state machine. Connect it over here. Right, open the state machine, right click, add state. This will be our idle state for now. So I'm gonna open it up and add the animation. So go to the echo anims, select the idle, so this is our idle animation. I'm gonna grab it over and place it over here and open the animation graph and grab the base locomotion layer and set it to our final output pose. So this is our idle state. Alright, so next thing is I'm gonna go to the event graph. We need some properties, so let me open my notes, just a moment. So first thing first, I'm gonna right click and promote the delta time to a variable, which is delta time x, right? And I'm gonna go to functions, function override, and there is our blueprint thread save update animation. So this is our thread save function, which we can use to calculate some parameter, for example velocity, acceleration, these sort of values in a separate thread. So I'm gonna use this function. I'll go to functions and create a new function. I'm gonna call this setup essential properties. Setup essential properties. Add it over here. Open it up. Sorry. I'm gonna click on the function, go to advanced and set it to thread save. Now I'll grab the function and place it and connect the function to blueprint thread save update animation. There we go. So now if I open my function and I'm gonna right click and get the property access node, and so first thing we need to get our movement component. So we need to access our movement component. In order to do that, let me go through my notes. Get movement component. Okay, so I'm gonna click on new function. I'm gonna call it get movement component. Alright, so this will be also our thread save function. I'm gonna right click at property access, try get pawn owner and get movement component. Then I'm gonna pass it to character movement component. Alright, so for all the thread save functions we should have an output which returns something. For example, this function returned the character movement component, so this function should have some output, and the output should be our movement component. So I'm gonna add it over here and remove it from there. So we need to call the output to return value. So if cost failed, we'll add it over here, return value. So this is our get movement component function. This will be our thread save function. As this is our thread save function, I'm gonna select and call it and set it to pure function, because this will use this function for getting some properties only. So now if I go to blueprint thread save function, open the setup essential properties, here's my property access node, and now we can now access the get movement component. So this is our movement component function available in our thread save property access, and now we can simply get our all the parameters properties. For example, we first need velocity. So here's our velocity. Right click and promote a variable, call it velocity. Next we need acceleration. So here's our current acceleration. I'm gonna right click and promote to variable acceleration. All right, and next we need the speed, so I'm gonna grab the velocity, get the length, right click and promote to variable and call it speed. All right, so one more thing, we also need input vector, so I'm gonna right click access movement component and input vector, get last input vector, and I'm gonna promote it to a variable, call this input vector. All right, so for now these are our four properties that we need to use. I'm gonna close the function now. So I'm gonna now go to event graph. So next we need to we now need some information that our character is in idle, walk, run, which state our character is in. So for that I'll create an enum for that. So I'll right click over into blueprints folder and into blueprints and enumeration. I'm gonna select enum and I'm gonna call it locomotion state. So this will represent the current state of our character. I'm gonna add three values. First will be our idle, so either our character is in idle, walk, or run state. We can add as many states as we want, but for now let's keep it simple, and I have added 3 states: idle, walk, and run. So this is our locomotion state enumeration. So next thing, I'm gonna create a new variable. I'm gonna call it locomotion state and set the variable type to locomotion state. That's it. And now we need to find the locomotion state. So if we are moving, our character should be in walking, running state, and if we are standing still, our character is in idle state. So now I'm gonna go to my functions and create a new function. I'm gonna call it find locomotion state. So this function will find the current locomotion state. So first thing is I'm gonna get velocity and get the acceleration. Alright, so I'm gonna get the normalized vector. So this will return our normalized vector, which is 0 and 1, between 0 and 1. So this is our normalized vector, velocity and acceleration vector. So I'm gonna get the dot product of these two and compare. So if first we need to find out the pivoting state. So if the acceleration is opposite side towards the velocity, which means we are moving towards the opposite side, so which turns the pivoting functionality to true. So we now need to compare it. So if it is less than 0, which means our acceleration value is less than 0. I'm gonna branch and print out, and we'll see. So I'm gonna print pivoting, and we'll see the result. So in order to see the results, we'll get the function and add it into the connect the function to update animation, so that our function is executing. So now you can notice, if I moving forward and press the opposite key, you can see pivoting prints. So this will which means we are in pivoting state. So if we are in pivoting state, then we need to set our locomotion state to, for now, set it to idle. We can also, so if we have the pivoting animations, we can add a new locomotion state and call it pivoting, and we can perform the pivoting animation. Right now we don't have any pivoting animations, so we'll just transition towards the idle, and then again we'll move towards the walking animation or running animations. So that's why I set the locomotion state to idle. And next we need to find either we are in running or walking state. So next, if our speed is greater than, let's say, 1, and so if speed is greater than 1, acceleration get the length. So if our acceleration length is greater than 400, because as the jog animations, the current jog animation speed is 450, so that's why I have set it to 400. So if our acceleration is greater than 400, and I'm gonna access movement component and max walk speed, and our max walk speed is greater than 250. So if these three conditions are true, which means we are in running state. Run. So for walking, I'm gonna duplicate the same functionality. So if our speed is greater than 1 and our acceleration length is greater than 0.01 and our max walk speed is greater than 1, which means we are in walking state. So if all these conditions are false, then we are in idle state. So this is the find locomotion state function is ready. So now if I go to the event graph, after the find locomotion state, I'm gonna use print string and get the current locomotion state. You can see currently we are in idle state. Now running, idle, run, idle. So this is our find locomotion state function. So our find locomotion state function is ready. Now we need to create a new macro for tracking the locomotion state. So for example, I'm gonna click on macro. I'm gonna name it track locomotion state. So this will keep track of our current locomotion state. So I'll add a new input, which is our current locomotion state. Locomotion state. So we also need one execution pin. So if our locomotion state is equal to current locomotion state, for the output we need 4 different execution wires. So first I'm gonna add 4 execution wires. So we have first on enter. For example, we have the running state, current locomotion state is run. So this will fire when we enter the running state on enter, on exit from running, while true, and while false. I'm gonna add a sequence pin over here and add 2 ones. Let me go through my notes. So if we are current locomotion state is true, we'll add a sequence, do once, and on completed we'll also need one more sequence from here. And I'm gonna duplicate the same functionality over here while false. So this will be our while true and this will be our while false. And for our enter and on exit, we connect the first sequence pin from here, reset this and this to reset this, and I'm gonna add it over on enter and on exit over here. So this is our track locomotion state is ready. Now if let me show you. So let's say we want to track the running state. So we'll set it to run. On enter, I'm gonna add print and run enter. Print run enter. On exit, I'm gonna print run exit, and while true I'll print running, and on false I'll print not running. So let's see the results. Currently you can see not running, running, not running. So you can notice over here this will exit fire once, not running, run enter, and then running. So we have all the states ready which we can use to track our different locomotions. So this is our track locomotion state function is ready.